There are three ways to represent an organic molecule. So if you're given a molecular formula, you can draw that molecular formula in three different ways. Either a structural formula showing the structural formula. What does that mean? It means that you show all the atoms and you show all the bonds. The condensed formula, you show the atoms, but you show no bonds. And in the skeletal or the line bond structure, we don't show carbons, we don't show hydrogens, but we show all other elements, and we only show bonds. So let's have an example. Let's say if I give you this molecular formula, let's start simple, C3H8, and I ask you go ahead and show the structural, the condensed, and the skeletal structure for C3H8. C3H8 is the molecular formula, okay? And I want to go ahead and draw it as a structure. So let's go ahead and start with the first type of representation, which is the structural formula. In this one, what you need to show is everything. You show the carbons, you show the hydrogens, and you show the bonds. So I start by connecting the carbons together. It is a Lewis structure, so it's the same idea as the Lewis structure. So structural formula in there is the same as Lewis structure, because in Lewis structure in there, I am showing the carbons, I'm showing the hydrogens, all the atoms, all the bonds. So you start by connecting the carbons. I have 3 carbons in there. And then I make sure that every carbon needs to have 4 bonds. Of course, I don't do this before checking out the identity of my hydrocarbon. As we said before, what is this hydrocarbon? This hydrocarbon follows the CnH2n plus 2. So this one is an alkane. So I know that all of my bonds in there are single bonds. This is why I do this, and I connect them all together and make them all single bonds in there. After I do this, I go ahead and fill all of these bonds with hydrogens in there, so that I use now 3 carbons and 8 hydrogens. So this is called the structural formula of C3H8, showing all the carbons, all the hydrogens, and all the bonds in there. So imagine if the molecule is really big, the structural formula will be really inconvenient to draw. And this is why we come to the next way to represent that organic molecule, which is the condensed formula. So in the condensed, you show the atoms only. You take out the bonds. So I show the carbons, the hydrogens here, I take out the bonds. And always, always start by reading any organic molecule as you write. So you write from left to right, you read from left to right. Never ever read it from the right. I always read from here. So I'm just going to leave you a note in there that says read the molecule from here. Okay, so always start reading the molecule from the left in there. And I don't want to show any bonds. So what I am reading here is a CH3. So I'm just going to go ahead and write it as a CH3. Next to it, I have a CH2. So I am writing it as a CH2. Notice no bonds in there. And then last, I have a CH3. So I'm just going to write it as a CH3 like this. And that is a condensed form. Now the skeletal, I don't show carbons, I don't show hydrogens, but I show only bonds in here. And again, I need to read the molecule from the left to the right every single time. So I'm going to start here. And what I have is a carbon. So see, I count the carbon chain. In the skeletal, it's really easy. And this is the way that we're going to go with when we represent organic molecule. So we have the carbon chain, which is the 3 carbons in there. So I'm going to represent every carbon by a dot. So this is 1 dot, this is the second, this is the third. And I draw them in a zigzag way. I don't draw them straight. There's a reason why I don't draw them straight in there. Because drawing the carbons straight like this indicates that the carbons are linear, and I know that they are not linear. I know that each one of these carbons is a tetrahedral carbon with a bond angle of 109.5 in there, because when I represent the carbon like this, this carbon has one bond, but it still has 3 hydrogens in there. Always follow the rule that every carbon needs to have 4 bonds. So if you have one carbon on the edge here, this means that the 3 bonds are hydrogens, okay? And when you want to draw the hydrogens, you still follow the same rule. 2 bonds in plane, one in front, the other one behind. You can draw them any way you want. But always we like the plane, the in plane in there to be over here. So you can put the in plane also here if you want. It's not a big deal as long as you follow the rule of 2 bonds in plane, one in front and the other one is behind there. So so that is considered to be the skeletal form. So notice the difference between each 3 of them. Let's have a more carbon chain example. So we are given now C5H12, and we are asked to go ahead and get its its structural, condensed, and the skeletal form of the N chain. And what does N chain mean? N chain means a straight chain. A straight chain, it does not mean that the carbons, they are forming a line with a bond angle of 180, because I know that this is impossible for each of these tetrahedral carbons. This is called an N chain. An N chain is a chain that has no carbons coming off it, meaning that no branches coming off that. So normally the skeletal chain is considered to be an N chain if there are no carbons coming off that chain in there. So we call it kind of like a straight chain, but it is not straight. So let's start with evaluating C5H12. It follows the CnH2n plus 2. So this is going to be an alkane. Alkane means that all the carbons are going to be bonded to hydrogens by single bonds. So I'm going to start by the structural formula, which is the same thing as the Lewis. And to draw this, I'm just going to connect all the 5 carbons together. It's the first thing I do. I connect all the 5 carbons together. Notice I always start the drawing from the left to the right, not the other way around. And then I know that every carbon needs to have 4 bonds. So I have 3 here. I have 2 here, I have 2 here, 2 here, and 3 there, okay? And then I fill those with hydrogens. This is going to be more than enough to cover the 12 hydrogens. Just count your carbons and hydrogens in there. Just make sure that you drew the right structure, and this is considered to be the structural formula. Now for the condensed, I'm going to start from here, and I'm going to draw it. Notice that this is an N chain. It is a straight chain in there, so this is why we call it an N chain. There is no carbon that is coming off the chain. It's just a straight chain from the structure. To draw the condensed, I'm going to start from here and read it from here. So I am having a CH3. That CH3 is connected to a CH2. So I'm just going to have my CH2 in there. And that CH2 is connected to another CH2. Notice, I'm just going to go ahead and put it right next to it. And then I have another CH2 here. This is the CH2. And then I do have a CH3, which is the CH3 in there. And I'm just going to go ahead and put the CH3. Whenever you have a lot of groups that are in the middle and they are the same, we condense them further, and that is called fully condensed formula. So I would write it in a different way now, or in another way, which is the CH3, open the parentheses, and you have how many CH2s? Count them. You have 1, you have 2, and you have 3 of them. So that is going to be 3, and that is a CH3. So the condensed formula for the C5H12 is this one. Not this one, it's this one in there, because this one is going to be the fully condensed. Okay? Just make sure that always you follow the VSEPR and follow the tetrahedral geometry whenever you are drawing the skeletal form. So never ever in the skeletal show the carbons as a straight line. You need to show them as zigzag. So to do this, I have 5 carbons, right? So I'm going to start always from the left. I'm going to have one here, one down, one up, one down, one up, draw 5 dots in there. And after you draw the 5 dots, you just go ahead and connect them. And that is considered to be the N chain. And this is your skeleton structure for the C5H12. We call this N chain. And we call this as well a straight chain. Okay, let's have another example in there. So given the following skeletal formula, so you have your skeletal formula in here, remember that you start with a carbon. So every dot is a carbon. Let's go ahead and highlight all of those. So these are all carbons. And I am asked to change into a condensed formula. So let's highlight them in there. And we're going to go ahead and read the molecule from always the left. So I'm just going to read the molecule from starting from this carbon over here. I'm using the condensed. So I'm going to start with a CH3. Okay. Why it's a CH3? Because this carbon has 3 hydrogens in there. Why it has 3 hydrogens? Because every carbon needs to have 4 bonds. This is a bond, so it's left up with a 3. This carbon here has 2 hydrogens. This one has 1 hydrogen. Maybe it will help if you do this at the beginning just to get used to it. This has 2 hydrogens. This has 1 hydrogen. This has 2 hydrogens, 3, 2, 1, and 3 hydrogens, 2 hydrogens, 2, and another 2. This is a 3. This is a 3. This is a 3 hydrogen in there. So let's go ahead and draw the condensed formula. This is going to be a CH3. Now next to the CH3, I do have a CH2, so that is going to be a CH2. Next to the CH2, I have a CH. This is a hydrogen in there. So that is a CH. Now this is called a branch. See how I have a CH3 coming off that CH? This one is called a branch. So to represent that branch, okay, I would go ahead and open the parentheses. And I know that in here, I do have a CH3. So that is going to be my CH3 in there. See, my long chain is this. This is going to be my straight N chain. And everything that is coming off that chain, we're going to call it a branch. So we're going to open the parentheses for them. So we're going to open the parentheses for the CH3. We're going to open the parentheses for the CH2, CH3, and so forth. Okay, let's go ahead and move on. So for this carbon now, that is going to be a CH2. That CH2 is connected to, again, a CH, and there, open the parentheses. Now on the CH, what do I have? I have a CH2 and a CH3. It's the CH2 that is connected to the CH. So I'm going to start with the CH2 here and then a CH3. I cannot do a CH3, CH2. That is wrong. So on the CH, the CH2 is connected and then the CH3. Let's move on in there. Then on this carbon there, I do have a CH2. This one is going to be a CH. Now on that CH, again, what do I have? I have my CH3 here. So let's go ahead and open the parentheses, and that is a CH3. This carbon over here is a CH2. This one is a CH2. I can condense it further, but let's not do this before we draw the full structure. That is a CH2 in there. No, it's not a CH2 actually. Yeah, it is. It is a 3 of them. It is actually 1, 2, and 3. So 1, 2, and 3. We're good. Now coming to this carbon over here now. So what do I have here? I have a carbon, and this carbon, oh, it's a mistake there. There is no hydrogen in here. Carbons, they make 4 bonds. They cannot make 5. So pay attention. So there is no additional hydrogen here. So I just have a carbon. Let's go ahead and move this a little bit. I just have a carbon here. So here you go. Okay. So I just have a carbon. This is going to be a carbon. Now, on that carbon, what do I have? I have these groups that are the same. I have a CH3, I have another CH3, and I have another CH3, and all of them are branches of that same carbon. I have two options. I can open the parentheses and put them all in one and do 3 in there. This means that all of these 3 CH3s belong to the carbon. Again, when you open the parentheses, this means that the group in the parentheses belong to the carbon before it. So this one over here belongs to the CH, and this CH3 over here belongs to the CH as well. This means that it's coming off that. I can do this, or I can do a C. I can do a CH3, and then I can do two CH3s there. Okay, whatever you want. Now, which one I prefer? I prefer always to group the groups that are the same always together. So can I condense this molecule further? Yes, because here I do have a lot of CH2s that are next to each other. I can simply condense them. So let's draw it again. This is going to be the final condensed structure for the molecule. So that is going to be a CH3, it's CH2, a CH, okay, CH2, CH3, and then a CH2, okay. This is a CH3. Now I'm going to open the parentheses in there since I am condensing them and put those two this is 3 CH2s all the way together like that. And then I have a carbon with the CH3s. I always like to put the groups that are the same, put them in parentheses and put them together. Now, what's the difference between a CH3 and a CH2? I know a CH3 is a branch of the carbon because every carbon has 4 bonds. But the CH2 is not a branch. CH2 is part of the chain, so pay attention to that. Let's have another example changing from condensed into a skeletal. For this one, you're going to neglect everything in parentheses if it is a CH3 or a CH2CH3. But if it is just a CH2 like that, you have to count that because CH2 is part of the chain. So I'm going to start numbering from the left, and I'm going to number every carbon except the ones, the CH3s in parentheses. I'm going to skip them because these are branches. So that's going to be 1, it's going to be 2, it's going to be 3, it's going to be 4, it's going to be 5, it's going to be 6. And there I'm skipping the CH3s in parentheses, but when I come to the CH2 in parentheses, this is part of the chain. This is a 3 carbon that I condensed it. So that is going to be carbon 7, carbon 8, and carbon 9 in there. And then I have the C, which is carbon number 10. So I have 10 carbons over here. So I'm just going to draw them as 10 carbons. Make it easy because it's not hard. So that is my 10 carbons over here. It says 1, 2, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm going to start my numbering exactly the same as I did. This is a 3, 4, 5, 6, 7, 8. This is 9, and this is 10, just to keep track of any of the branches in there. And then I'm going to go into carbon number 2. So carbon number 2 has a substituent, which is a CH3. It's coming off that. So I'm just going to go ahead and put the CH3 there. Carbon number 6 has a CH3 coming off that, so I'm just going to go ahead and put that there. And then carbon number 10, what does it have? It has a 3 CH3s that are coming off 10, so I would need to put the 3 CH3s. This is 1, this is 2, and that is a 3. And this is going to be the skeletal form. And I forgot to add a CH3 over here because you have 2 CH3s coming off carbon number 2. So these are 2 CH3s in there. Don't forget to do this because this carbon has no hydrogen. This means that this carbon needs to have 4 bonds, and these are the 4 bonds around it. Here I've condensed, changing it into a structural formula, Again, we're going to start reading it from here. And now for this one, I'm just going to read it as I go. So I have a CH3. Remember, structural, you need to show the bonds and the atoms, everything. You show everything. So I have a CH3, so I'm just going to go ahead and put the CH3 like that. So move one atom at a time. That is connected to a CH2, so this is a CH2. It's connected to a CH, so that is a CH. Now on the CH, what do I have? I have a CH3 in there. So I'm just going to go ahead and put the CH3 as a branch. So that is a CH3. Notice what I did. When you add a branch, just either add it down or add it up. Leave that line to the long carbon chain, okay? Now, next to that CH, I do have the CH over here. So that is going to be the CH. And again, you can put the hydrogen here, the CH3 there. It really doesn't matter. So on that CH, I have a CH3 coming off that. So here you go. That is going to be a CH3. You know what? I'm just going to put the CH3 up there so that I would have enough room for the hydrogen here and then the CH3 over here, just to show you that it really doesn't matter where to put the CH3, but it looks nicer and better if you leave the straight chain like that to the long carbon chain and put any of the branches on the sides. And then I do have a CH2. Right now I am here. This is the CH2, and then I have my CH3. And this is going to be my CH3 in there. So that is the structural formula. Let's have another example. So this one, I want to change it into a skeletal. So to change it into a skeletal, remember what we said. We're going to neglect anything in parentheses if it is a CH3 or a CH2, anything other than a CH2 in parentheses, so just neglect it. And start numbering from this carbon. So that's going to be 1, 2, 3, 4, 5, and 6 in there. So I have my 6 carbons. So I'm just going to go ahead and draw my 6 carbons. 1, 2, 3, 4, 5, and 6. On carbon 1, what do I have? I have a CH2, CH3, and I have 2 of them. So number your carbons just to keep track. 4, this is 5, and that is 6. So on carbon number 1, I have a CH2, CH3. I have a CH2, CH3 in there. So see, this is the same as that, and it's 2 of them. And then on carbon number 5, I have a CH3. So here you go. That is on 5, I have a CH3 in there. Remember, each one of those is a tetrahedral geometry in there. And then I do have on carbon number 6 now, I have a CH2, CH2, CH3. See, the CH2 is connected to the CH. So on carbon 6, I have 2 of them. I have a CH2, CH2, and a CH3. And then I have a CH2, CH2, and the CH3. You can go in any direction you want, but make sure that it is 3 carbons here and the 3 carbons there, okay? That is the skeletal form. Now, of course, the heteroatoms can also be there. So it's exactly the same thing. Those heteroatoms are still branches. So if they are branches, they're going to be coming off the main chain in there. So again, you're going to treat them like a CH3, and you are going to put them in parentheses. For this example, we do have a case of a branch on a branch. So if you look at carbon number 4 is connected to a CH, and on that CH, I have 2 CH3s. So all what you need to do is just open a big parentheses. Let's highlight. Open a big parentheses on carbon number 4, because everything that belongs to this parentheses is actually on carbon number 4. And then you do have a CH, so that is the CH. This carbon is this one over here. And then on that CH, open the parentheses again, and you have 2 CH3s that are connected to the CH. And then move along in order to write down the condensed formula of this skeletal structure.